All right, let's go ahead and try another factoring one here. Can you solve this one by factoring? This one's a little bit more challenging because it doesn't have a leading coefficient of 1. See if you can go ahead and factor that. I've gone ahead and factored it, and when I solved it, I get x equals 3 halves, or 1.5, or x equals to -6. Now, I'm going to ask you to do the same thing, graphing this on Desmos. See if you can get the same two solutions, x equals 1.5 or x equals to -6, by using Desmos. All right, so here I've graphed y, the same equation here, where when y is equal to 0, that's where it crosses the x-axis. So I graph the equation, look at -6 and 1.5, and sure enough, those are the same two solutions that we had before. All right, let's go ahead and try an application of this here. Alvin kicks a soccer ball from the ground up in the air. As it leaves his foot, it has a speed of 32 feet per second. The quadratic equation that represents the vertical height of the ball is represented by the equation h, which is the height in feet, is equal to -16t squared plus 32t, where t is measured as the time in seconds. How long does it take for the ball to reach its maximum height? How high does it get? And how long does it take for it to hit the ground again? All right, so see if you can use Desmos by plugging in this equation in there, and see if you can, how many of those questions that you can answer. By the way, this -16 here is actually always, that's a constant that's going to be in these kind of gravity problems here. That's actually the force of gravity makes this, the acceleration here, -16 feet per second squared. And that's where that number comes from. This 32 is actually the initial velocity here of 32 feet per second. And a lot of times we'll even have a constant term here, which is the initial height. This one has an initial height of 0, so we actually don't put that part in here. We will be using these kind of problems later on in the unit, but this is just an introduction to see for the principles that we've just been learning. So see if you can go ahead and graph that and see if you can find the answers to those questions. Okay, so let's take a look. Here's the equation here. Here's the graph. We start off at time 0. Interesting enough, the parabola goes back to negative time, so this is irrelevant, this information back here. We have the soccer ball is going to go up. The vertical height keeps going. It's starting to slow down as gravity slows it down, and eventually it hits its peak after 1 second for a height of 16 feet maximum. And then the soccer ball starts to fall again. And where does it hit the ground? Right here after 2 seconds. So we've answered all of the questions by using our graph. All right, what about if we do this by factoring? All right, by factoring here, I'm going to factor, again, if we're going to try to find when the height is 0, let's say we're trying to find that part first. Let's set 0 in for the height. And then we're going to factor this one. This one's a little bit different kind of factoring. I'm going to factor out the greatest common factor. Looks like -16t. I can factor out of both of these terms. So I factor out a -16t. That leaves me with a t for this term and a -2 for this term. So I get t minus 2 here. And now when I solve this, we have 3 factors. We've got -16 times t minus 2. And in order for those 3 factors multiplied to equal 0, either the t must be 0 or the t minus 2 must equal 0. And so if you solve each one of those, we get t equals 0, which is actually when the ball starts being kicked, or t equals 2, that's when the ball is landing after 2 seconds. The average of those two numbers is actually 0 plus 2 is actually 1. So the average of those two, that's the time it takes to reach its highest point, is 1 second. And if I plug the 1 back into the original equation, I am going to get a height of 16 feet as my maximum height.